Right, now we're going to talk about improper integrals. And so the easiest sign that you've got an improper integral is when there's an infinity involved in one or both of the limits of integration, and that's the one we're going to talk about now. The other one you want to be careful about, which is a little more mysterious, is if there's a vertical asymptote and you're integrating across that vertical asymptote, then you have to turn that into an improper integral. Um, and and then take a limit as you're approaching that vertical asymptote. You may remember some problems like that. In this case, you maybe just watched the integration by parts video. It looks like this is maybe an integration by parts problem because we've got an x times an exponential, but this x squared sort of changes the game. The derivative of negative x squared is negative 2x. And so I can actually take the antiderivative of this with just that correction factor or use substitution. So to turn the negative 2x into x, I need the 1/2 there. And then I have the exponential. So the derivative of the exponential is itself multiplied by negative 2x. Sure enough, I get the x back. They will always, when you show your work for this, they will always want you to turn it into a limit. And so we're going to take the limit as t approaches infinity, and then we'll make that upper bound t. You don't want to treat infinity like a number. You want to turn it into a variable and take the limit. And so now I'm going to have limit as t approaches infinity, negative 1/2 e to the negative t squared minus negative 1/2 e to the negative and then 2 squared. And so now we have to think this through. What's going to happen when t is a big positive number? Well, we're going to square it and then make it negative. So I'm going to have e to a huge negative power. That's 1 over e to a huge positive power, which turns into 0. And so minus and minus becomes plus. So I get 1/2. And remember, order of operations, once again, we square the 2 and then we make it negative. So the final exact answer of this is 1/2 e to the negative 4th. Improper integrals.